Hello, I'm going to present my presentation about comprehensive review on the benefits of user neuron connection.
Sorry, can you share your screen?
Uh, is it not? Is it?
Okay.
Okay. Thank you. Thank you. So I'm showing my presentation about comprehensive review on the learning techniques. And what we're doing in the paper is we provide a comprehensive review on how the learning techniques can improve the reinforcement learning machines. What's the motivation behind the research? It depends on who is the reader. For the people who are aware how the deep reinforcement learning works, it can be very useful guide about their fine tuning of their machine. And for the people who are not very sure how the deep reinforcement learning works, they can uh, see the basics of the topic. So what are the pruning techniques? Well, if you think how the brain works, it matures when only the most important connections know. This is how the biological brains mature and how the artificial brain mature. Yes. So we're going to see how we can accelerate this maturation with dropping techniques. Experiments. We have several artificial brains, and we force them to play attack games with different scales of drop techniques or ignoring of the connections during the training process. And we keep track of the several statistics that can explain benefits of these techniques. First of all, how the deep reinforcement learning works and how we use artificial networks. Imagine you are forced to play the game and the input will be what is shown in the screen. For example, this swimmer and the octopus. The output of the networks is the possible actions. And if the actions gives points, they should be remembered. If they don't give points, the networks should be forced to adjust and reinforcements different actions, of course. And what about the drop techniques? This is the important things we try to understand here. So imagine you're a human and you are going to play this game, but you just see random pixels. What you do? You ignore everything and try to focus on these pixels, on that pixel, until you find what actually is meaningful. Well, this is the exact same way that the drop technique in the reinforcement learning works. It is randomly deciding to not update some connections, where the brain randomly decide to ignore some pixels of the game until they are proven they bring some information that is useful. I think this is a good way to understand what is the drop techniques, what is the pruning techniques, and how they benefits the reinforcement learning. And what we're learning after these experiments, we find two very important things that can be useful. And these things. First, what will happen if we force the machine to take the whole input to concentrate on the every single pixel and everything that happened in the game? Well, it simply does not ever learn how to play the game, no matter how much episodes or how much training it go to. It just doesn't learn how to play the game. But we find out that you can ignore up to 70% of the whole information that comes here by just refusing to update the connection in the networks. And you will still yields very good results. However, after ignoring more than 70% and increasing the drop rate to the 80%, it starts to give the very bad diminishing returns since since no information is used to retrain the networks, of course. And the second important thing that is useful for the researchers is, of course, the log is the number of the train connection in the networks. The less time it goes into the training of the machine. Sorry, am I connected? Am I connected? So I think I'm still connected. Okay. I only choose this tool, but in my paper way more and many infographics that can be useful for the engineers in their fine-tuning of the networks that can be useful. And this is the conclusion. We provide very useful infographics that can be used in practice for your fine-tuning of the machine. And we show that these techniques are very useful, especially in Fox modeling, and can lead to even improving the computational time of the networks. Those are my contacts. If you like to send me email with question for future collaboration. And yeah, thank you for attention. Do you have any questions?
Thank you for presentation. Is there any question? Okay, thanks again.
Thank you.
Next presentation, dear Andre.
I'm here. I'm ready.
Okay, you can start.
Okay. Now I share my screen. One moment, please.
Okay.
I want to present the result of our research and our method for assessing matter error characteristics of random signals. The distribution of the characteristics of random signals is the study of various physical phenomena, technological process, and technical objects, if substantiated. The absence of theoretical material for the analysis of error in measuring the characteristics of random signals during digital processing with the corresponding matter is shown. Emphasis is placed on the fact that error in measuring the characteristics of random signals can significantly affect the result of determining the state of technical systems. The purpose of the study is to develop a method for estimating the error of matters measuring the characteristics of random signals. A method for the estimating the error of measuring the characteristics of random signals is proposed, which is based on the rational algorithm for calculating sample variance, estimating the permissible values of the error in measuring the statistical characteristics of random signals, including assessing the influence of the accuracy of measuring sample elements on the accuracy of these characteristics. It is proposed to use the result obtained in the construction of methods for the characteristics of random signals and in the development of methods for determining the state of technical systems using the characteristics of random these signals. Research results. The characteristics of random signals have found widespread use in the study of various physical phenomena, and technological process and technical objects. For example, when diagnosing the technical conditions of engines of different types, diesel, gasoline, electric, using the vibration diagnostic method, the characteristics of random signals that appear in the engine's operation during certain malfunction are studied. The results of evaluating the obtained characteristics of random signals make it possible to determine not only the current technical condition of engines, technical objects, but also to draw conclusions about serviceability over a certain period. Carry out diagnostics. The average result estimates for dispersion and standard deviation of characteristics estimates of random signals are the main statistical characteristics of this signal. Therefore, methods and means for measuring the main characteristics of random signals have found wide application in instrument make and electrical radio management. In this case, preference is given to digital device meters, which are mainly produced as they have a number of advantages over analog ones. Well-known works and scientific and technical literature present a simplified approach to present the basis of conclusion method for the characteristics of random signals. Law diagrams and algorithms for calculating statistical or sample characteristics are given. However, there is no theoretical analysis of the measurement errors of these estimates during digital processing performed in meters. It should be noted that errors in measuring the characteristics of random signals can significantly affect the result of determining the state of technical systems. The purpose of research is to develop a method of estimating the error of meters of characteristics of random signals was given. The work defines a rational algorithm for calculating sample variance, obtains estimates of the permissible values of errors in measuring the statement characteristics of random signals, including an assessment of the influence of the accuracy of measurement of sample elements on the accuracy of their determination. For the algorithm for calculating the simple dispersion of random signals, two hardware implementation options are proposed. It is theoretically justified that in terms of simplicity of hardware implementation and speed, the second version of the calculation algorithm is more rational. The result obtained are proposed to be used in the construction of meters for the characteristics of random signals and the development of methods for determining the state of technical system using the characteristics of random signals. That's all. My report complete. Thank you for the intentions. If you have any questions.
Thank you for presentation.
Thank you too for the
Do you have any
intention.
question? Okay, next presentation, dear Ahmed Farooq. Dear Farooq,
Can you hear me?
yeah, you can start.
Okay, just give me a second, and I will start it. So you can see my screen?
Yeah.
Okay, so my name is Ahmed Farooq, and I have done my graduation from in mechanical engineering from NFC Institute of Engineering and Fertilizer Research, Faisalabad. My co-author is Mohammad Imran. He's from RIT Dubai. So the paper title is Innovating Vending Machine Through Object Detection for Currency Recognition and Enhanced Cash Handling. So the outlines are the background, introduction, objectives, literature review, methodology, working principle, hardware architecture, results, conclusion, and future recommendation. The background. The primary motivation for the development of this groundbreaking vending machine was a lack of local manufacturing in Pakistan. To overcome this obstacle, it was crucial to keep two things in mind. First, the embedded system should be constructed of hardware components that are easily available. The second is to develop a model for currency recognition that doesn't require a huge data set for training, since the currency data set is not available in Pakistan. Keeping in view of these two aspects, we employed a transfer learning object detection model that doesn't need a huge dataset and Arduino with the ESP232 CAM-based embedded system hardware, which is a testimony to the spirit of innovation. Introduction. This research study presents the concept of a vending machine that has the potential to modernize the vending sector by employing object detection and friction fading techniques. The integration of ESP32 CAM into the design perceptor, which enables real-time currency recognition through the object detection model of transfer learning, is at the core of this innovation. The mechanical cash transit system compatible with the Arduino Pro Mini is designed to replace the commercial perceptor. A friction fading technique is deployed for reliable remaining cash transactions, and a complex embedded system is powered by microcontrollers. The objectives of this research is to develop an advanced vending machine with integrated currency recognition and cash transit system, to develop a friction fading mechanism for reliable remaining cash transactions, and to investigate the system's reliability through testing, to explore the future developments on the basis of results. Now, the literature review. Researchers have developed the advanced vending machine using Arduino Nano, which is a very simple one, then a rack and a pinion gear system for the dispensing of the products, then electronic payments, IoT systems, and cascade classifier for object detection. And like it was for the reverse vending machine and the plastic bottle collection. Enhance their autonomy and efficiency. Then for the friction fading technique, researchers have developed patents and models for smooth and accurate paper transportation, including money recognition, currency movement, friction-based paper transportation, and modern paper feeding methods. These advancements aim to prevent double picking of cash and improve efficiency in paper transportation. Then for the object detection model, research have developed methods to differentiate real currency from counterfeit. Nike have developed a methodology which uses image processing that the grayscale conversion, that is the grayscale conversion, and then after it detection, and then segmentation, feature extraction, and comparison to determine currency authenticity. The Khan discuss computer vision and hard cascade classifier for object detection. The methodology we use for this prototyping is, after analyzing all these studies, we came to the conclusion that we should develop a vending machine that is compatible with an advanced dispensing mechanism for products, currency recognition through object detection, and the friction feeders for smooth and precise cash transit. As all the working principles of the vending machine are in the form of patents, this study introduces a new methodology to be employed. The working principle. The vending machine uses computer vision instead of scanning currency, making it adaptable to any country's currency. It trains the model on a dataset and uses IR sensor to detect currency movement. The microprocessor then communicates with Arduino Pro Mini to transport the currency through roller movement. The machine uses a keypad and a graphic interface user, a GUI. A user interface to select products, communicates with Arduino Uno to drive the motor and deliver the cash to friction fading for smooth transit. In the figure, it's a flowchart, like to start, then you have to insert the cash, and after that, the IR sensor will detect the cash is here, and then Arduino Mini Pro give a signal to the stepper motor driver, and then the stepper motor driver is actually controlled by the microcomputer. And then the microcomputer actually makes some image processing. If it is not a counterfeit and it belongs to the class of the currency which we have given in the data set, then it will be true. Otherwise, it will be false. And after that, the GUI will show that now you can select the product. The product will be selected to the keypad, and then Arduino Uno, which is used for dispensing products. And actually, there are 10 pins here which are actually connected to stepper motors to dispense the products. And after that, in return, then the Arduino Pro Mini is responsible for the reliable remaining cache transaction. So hardware architecture. Main power supply provides power to electronic components. Arduino Pro Mini is connected to ESP32 CAM through FT232 port. LCD and keypad transfer signals to Arduino Pro Mini for product selection and interface. Arduino Uno and Pro Mini are communicating through TX and RX connections to product dispense. It means that they are going to deliver the signal, and after that, they can also receive the signal from each other. The hardware components we use for this, that's a Arduino Uno, ESP32 CAM, Arduino Mini Pro, IR sensor, A4988 stepper motor drivers, stepper motors, GUI, keypad, rollers, power supply, trays, and springs. Prototyping journey. This was the whole raw material, raw form, like from a very left position, top left, this is the power supply, and as well as the Arduino Uno is there. The breadboard, which is actually used to dispense a signal to the stepper motor, the 10 stepper motors are there. So after that, the second one is the prototype mechanical designed Billiceptor, which is a replacement for the commercial Billiceptor. And then there's the GUI, and after it, in the end, there are the motors in the raw form. And after that, this is the vending machine on the very right side of it. This is the product, finished product, prototype. And then the results. The functionality and effectiveness of the proposed model are examined through the comprehensive range of investigations and assessments. The design Velocity shows remarkable accuracy, not only in fluency recognition through the integrated ESP32 CAM, but also in the smooth transportation of currency from insertion to drop in the money box. The reliability of the remaining cash transactions through the friction feeder and dispensing mechanism of product is similar to that of a commercial vending machine with a small margin of error. Results. Currency detection trained model results. In Edge Impulse Feature Explorer examines features of the test image or object that resembles with the feature extracted from dataset. It provides relevance, correlation, analysis, and visualization on axis as shown in the figure. This is the figure, Feature Explorer, which is actually the Note 100 and the Note 50. They're the two classes we made for the initial training dataset. Then the results. Currency detection trained model. FN score. FN score is an ML evaluation metric which measures the accuracy of a model. It blends the accuracy of a model and memory scores. The accuracy metric calculates correct prediction of a model made from entire data set as shown in figure. Our FN score is 59.3 for the 100 rupees note. This was the pre-trained model, so our main accuracy is 71%. Now, the currency dataset trained model. The accuracy of ML model shows the correct predictions from total number of predictions. The accuracy of this trained model is shown in figure that is 70.83, which is the trained model accuracy, and it can be increased after training it for more period. Now, the currency detection experimental results. As the prototype uses ESP32 CAM module to capture and process currency notes using transfer learning model of object detection for accurate denomination and prediction. ESP32 CAM captures image showing currency class is 100 and confidence is 94%. This is the 100 rupees note of Pakistani. So, and it shows the confidence 0.94% that it is a 100 rupees note. And this is the FN score also. Now, the results. The model
Dear Faruk.
Can you hear me?
Yeah.
Okay, so I have to start it from, I have to do it from the start or from where? Like we
Okay,
have
no
interrupt.
problem.
Okay, so from where I have to start right now? Okay,
Thank you for presentation.
okay.
Do you have any
So
question?
I think I have to end this. So my slides are remaining right now.
Okay.
Okay, thank you. So this is the thing. Like we have designed the transfer learning through TinyML model whose accuracy is more than 70%, and the commercial bill acceptor accuracy is 94%. But it's an initial approach, and we want to go to the deep neural learning network, whose accuracy is 94.5%, and whose value will also be lower than the commercial bill acceptor. So in conclusion, this vending machine is an enormous breakthrough for vending technology as it has computer vision for currency recognition through an ESP32 CAM-based object detection model. It is also integrated with the product and cash transportation system controlled by Arduino. In the friction-free technique for the cashback mechanism, the prototype 71% accuracy in money recognition, as validated by comprehensive testing, is an encouraging approach. The motivation behind this is to build a prototype to overcome the obstacles of local manufacturing of vending machines in Pakistan, where the availability of local currency dataset, modern hardware, and bill acceptor is limited. However, it marks the start of an entirely new wave of vending machine technology. And there are the future recommendations. Furthermore, the capabilities of this vending machine can be enhanced by incorporating a deep learning neural network model for currency recognition, which will boost accuracy to 96%, an electronic payment option, and an IoT-based inventory control monitoring system. So thank you.
Thank you for presentation.
Okay, I have to be in the room, or I can leave now. Hello.
Sorry.
I have to be here, or I can leave now.
Yeah.
Okay, I can leave.
Okay.
Okay, thank you.
Thanks again. For the presentation, dear Atar El Azavi. Dear Rashid Ahmed. Dear Mustafa Murat Hamdi. Okay. Do you have any question? Your certificates will be uploaded to paper management system. You can download it from there. Thanks for your contribution. See you in the next session.